State. Solid state is nothing but one of the states of matter. In our early days of schooling, we learned that matter exists in three states: solid, liquid, and gas. However, as we progress from lower to higher classes, the concepts gets more advanced and there are more things to learn. In this lesson, we will be dealing with the concepts of solid state and a broader aspect and understand all the underlying terms including the properties as well as the types of solid. Solid generally exhibited certain characteristics that set them apart from liquid and gases. For example, they have the ability to resist any force that applied to its surface. However, the solid state of compound largely depends on the properties of atoms such as their arrangement and the forces acting between them. Physical and chemical properties of solids. Solids are incompressible, meaning the constituent particle is arranged close to each other, and because of that there is negligible space between the constituent particle. Solid are rigid. This is due to lack of space between the constituent particles, which make it rigid or fixed. Solid have definite mass, volume, and shape due to which it has compact arrangement of constituent particles. The intermolecular distance between molecules is short. Due to this, the force between the constituent particles, atoms, molecules, or ions is very strong. The constituent particles can only oscillate about their mean positions. Solid state chemistry. Solid state chemistry is the study of the structure, properties, and the synthesis of solid materials. It is also sometimes called as materials chemistry. More significantly, in solid state chemistry, we study the concept of a compound at a more deeper level. It basically helps us understand the compound from a molecular level to the crystal structure level. In solid state chemistry, non-stoichiometric compounds are categorized as exclusive solid state compounds due to their structure and thermodynamic characteristics. Types of solid states. Based on the arrangement of constituent particles, solids are classified into two state types. Number 1, crystalline solid. Number 2, amorphous solids. Crystalline solid state. Crystalline solid are those that have a typical geometry. In such types of solids, there are definite arrangement of particles, atoms, molecules, or ions throughout the three-dimensional network of a crystal, and a long range other examples include sodium chloride, quartz, diamond, etc. Properties of crystalline solids. Crystalline solids have a sharp melting point and start melting when it reaches a particle temperatures. The shape of crystalline solids are definite and having typical arrangements of particles. They show cleavage property. Example, when they are cut with the edge of a sharp tool, they split into two pieces, and the newly generated surfaces are smooth and plain. They have definite heat of fusion, amount of energy needed to melt a given mass of solid at its melting point. Crystalline solids are anisotropic, which means their physical properties like electrical resistance of refractive index show different values when they are measured along with different directions and the same crystal. Crystalline solids are true solids. Types of crystalline solid. On the basis of the nature of intermolecular forces or chemical bonding, crystalline solids are further classified into four categories. They are below. Number 1, molecular solids. Number 2, ionic solids. Number 3, metallic solids. Number 4, covalent solids. Molecular solids. And molecular solids, the constituent particles are molecules. They are further divided into three categories. Number 1, nonpolar molecular solids. These solids are formed from molecules or atoms that share a nonpolar covalent bond. The atoms of molecules are held by weak dispersion force or by London forces. The physical nature of nonpolar solids are soft. They don't conduct electricity, so they are insulators. They have a very low melting point, example H2, C12, I2, etc. Number 2, polar molecular solids. These solids are held together by polar covalent bond and the atoms slash molecules are bonded by relatively strong dipole-dipole interactions. The physical nature is soft and most of these are gaseous or liquid at room temperature. They do not conduct electricity and they have a higher melting point than the nonpolar molecular solids. Example HCl, SO2, NH3, etc. Number 3. Hydrogen bonded molecular solids. The solids contain polar covalent bonds with hydrogen, fluorine, oxygen, and nitrogen atoms. And these solids molecules are held together via strong hydrogen bonding. The physical nature of such solids are hard. They do not conduct electricity. The physical state of these solids are volatile. Liquids are soft solids under room temperature. They have a low melting point. Example H2O, ice. Ionic and metallic solids. An ionic solid, the constituent particles are ions. These are formed by the arrangement of cations and anions by strong Coulombic forces. These are hard and brittle in nature. Ionic solids act as an insulator in a solid state but are conductors in a molten and aqueous state. They have a high melting point, example NaCl, MgO, ZnS, CF2, etc. Metallic solid metallic solids. Positive metal ions and a sea of delocalized electrons. These electrons are evenly but spread out throughout the crystal. Due to the presence of free and mobile electrons, they are responsible for high electrical and thermal conductivity. They are conductors in both solid and molten state. The physical nature of these solids are hard, but they are malleable and ductile. They have high melting point than ionic solids. Example Fe, Cu, Ag, Mg, etc. Covalent and amorphous solids. A wide range of crystalline solids of non-metal from covalent bonds between adjacent atoms throughout the crystal and form a giant molecule or large molecules. These solids are hard like a diamond, soft like a graphite, which are isotopes of carbon. They are insulators as in the case of diamond, but in case of graphite, due to free electrons, they conduct electricity and act as a conductor. Amorphous solid state. Amorphous solid state comprises of those solids which have the property of rigidity and incompressibility, but to a certain extent they do not have a definite geometrical form or long range of order. Example include glass, rubber, plastic, etc. Properties of amorphous solids. Amorphous solids are gradually softened a range of temperature, and they can be molded into different shapes on heating. Amorphous solids are pseudo-solids or supercooled liquids, which means they have a tendency to flow very slowly. If you observe that the glass panes which is fixed to window of old buildings, they are found to be slightly thicker from the bottom than at the top. Amorphous solids have irregular shape. Example, their constituent particles do not have definite geometry of arrangements. When amorphous solids are cut with a sharp edge tools, they form pieces with irregular surfaces. Amorphous solids do not have definite heat of fusion due to its irregular arrangement of the particles. Amorphous solids are isotopes in nature, which means the valuable of any physical properties would be same along and direction because of the irregular arrangements of particles. Amorphous solid uses. Amorphous silicones, which is one of the best photovoltaic material, converts sunlight into electricity.